Good afternoon. Good afternoon once again. I welcome you to today's physics class. And there was some error in the last class which we need to rectify. So in today's class, I promise that the class will went smoothly as planned. Yeah. Without wasting much of our time, according to the scheme on grant, we want to start with fundamental and derived quantities. And units. Physics. So we want to talk about last week we talked about what physics is all about, concept of matter. Today I want to talk about fundamental and derived quantities and units. And this topic holds the most key aspect of physics because that is all what physics is talking about, deal with. Remember that last week when we were trying to define physics, we defined physics as a branch of science that deals with the properties and nature of matter and energy. So meaning that we will be dealing with matter and energy, and that is why we talk much about matter in our previous class. Today, now we'll be talking about the fundamental and derived quantities and units. So let us talk about fundamental units. Then after we talk about fundamental units, we can talk about derived units. So when we talk about fundamental units, what do we understand and what are they talking about? So fundamental units are the accepted standard units or measures in which measurement is made. The accepted standard unit or measures in which measurement is being made. That is what refers to as fundamental unit. It is acceptable all over the world. So that is what refers to fundamental unit. The fundamental units frequently used in physics are, so we talk about meter, which for N, we talk about meter is the unit of length. Another fundamental unit is kilogram. Kilogram, which is kg, is the unit of mass. We are dealing with fundamental units. All this length and mass, they are quantity, but we soon get there. So we talk about second, which is S. And this is fundamental unit of time. Another thing we talk about ampere. Ampere, which is A, is fundamental unit of current. So another one is Kelvin. Kelvin, a fundamental unit, Kelvin K. It's fundamental unit of temperature. Candela. Candela, fundamental unit of luminous intensity. Weber, the fundamental unit of magnetic use. So let us look into this again. We are talking about the fundamental units. And I told you that fundamental units are the accepted standard units, so or measures in which measurement is being made. These units are accepted and standard units, so that they're acceptable by every people. They don't change all over the world. And these units are what we use to measure what? To measure this quantity. The unit to measure length is meter. The unit to measure mass is kilogram. The unit to measure time is seconds. The unit to measure current is ampere. Temperature, Kelvin. Luminous intensity, candela, CD. Magnetic fluids, Weber, W. So here are the fundamental units and their fundamental quantities. So let's talk about derived unit now. Let's talk about derived unit. Derived unit. So we just talk about fundamental units. So let's talk about derived unit. Derived unit. So derived units are new units. We refer to them as new units or no fundamental unit derived from fundamental units. Derived units are being derived from fundamental units. We refer to them as new units or no fundamental units that are derived from fundamental units. That's why we call them derived units. So they are derived from combination of fundamental units. Combination of fundamental units, that's where they are derived. So the unit of acceleration is meter per second squared. Do not forget, we're trying to explain derived units. Derived units are non-fundamental units. They are being derived from fundamental units, either from a fundamental unit or from a group of fundamental units. That is where derived units being derived. For example, now, let's look into how derived unit is being made. Now, let's write about area. Area is a quantity. Area now is a physical quantity. Area is a physical quantity. So every one of us understand the formula for calculate area. The formula for calculating area is length times breadth. And the symbol for area is what? A. We all know that. This is the formula for calculating area. Now, to find the unit or the derived unit of area now, it is just very simple. And this is how the derived units are being derived. Remember, area, A, is equal to length times breadth. When we were talking about fundamental unit before, we been mentioned about length as a fundamental quantity. And the fundamental unit of length is meter. So we use meter as meter is a fundamental unit to measure anything that deal with distance or displacement, length, height. So we use meter for it. So when area, if area is equal to length times breadth, and the unit of length is meter, breadth also, the unit of breadth is also meter. I don't want to rush this class so you all can understand. Remember, the area is equal to length times breadth. Now, the unit of length is meter. The unit of breadth is meter too. Now, length times breadth, the unit of them is m times m. And this will give us, this simply means that the derived unit of area of this physical quantity area, so is equal to meter square. As simple as that. The derived unit of area is meter square. Now, we derived the unit of area now from length and breadth. We derive the unit of area from length and breadth. And that's what derived unit is talking about. Let's look at another example so you can understand the concept of this topic. We look into a normal example. Let's talk about volume. Volume is another physical quantity. Please, whatever I'm explaining here, you people should be taking note of it, because as time goes on, as we be moving on in physics, so all these things will be very useful for you. And I just want you to be like, whenever you come across it, you should understand what we are talking about. Now, volume, the symbol of volume is V. And the formula for calculating volume is equal to area times height. Area times height is the formula of calculating volume. We are trying to derive the units of volume from this quantity, area and height. Do not forget that the formula of calculating area is equal to length times breadth. And times this height. Height is h. It's standard. We're trying to find the derived unit of volume. And we are going to get the derived unit of volume from this quantity, area and height. The unit of length, we all know that is meter. The unit of breadth is meter. The unit of height is also meter. The height of something. If you want to measure the height of something, we are dealing with meter. The unit of height is also meter. Now, therefore, when we say meter times meter times meter, this will give us meter cube. M raised to power 3. Meaning that the derived unit of volume is meter cube. Meaning that any calculation that deals with volumes ended with what? Meter cube. As simple as that. Volume, area times height. Area is length times breadth, as we explained earlier. Height, h. Length, the fundamental unit of length is meter. Fundamental unit of breadth is meter. Fundamental unit of height is meter. That's fundamental. The one that we call as generally acceptable. Therefore, to find the derived unit for volume now, this will become meter times meter times meter. This meter is to power 10. This is the derived unit of volume. As simple as that. I hope you understand. Let's move on. We are dealing with derived units. Derived unit, let's talk about speed. Speed is another physical quantity. The symbol of speed is S. And the formula for calculating speed is equal to distance all over time. If you want to get the speed of a car, of a vehicle, of anything, you must understand, you must get to know the distance covered by the car and the time taken for the car to cover the distance. So, and when you get to know that, you get the speed of the car. Now, let's try to find out the derived unit of speed. Speed, symbol S, the formula is distance over time. Do not forget, distance is also deals with the length, okay, how far something be. And the fundamental unit of distance is meter. The fundamental unit of distance is meter. While the fundamental unit of time is seconds. So to find out, to get the derived unit of speed now, this will become this meter all over second. Therefore, the derived unit of speed is equal to meter per second. Anywhere you go, the unit of speed is always meter per second. It doesn't change, it will never change. Meter per second. Meter per second. Now let me take it gradually. So help you understand speed. We can move to velocity. Velocity now. Velocity. Velocity, the symbol for velocity is V. And the formula for calculating velocity is displacement all over time. We used to get confused about the differences between displacement and distance. Distance is what it covered. If I put this container here now, and later I shift it from this side, come and put it here. We cannot say that the distance this container covered. What we can talk about here is displacement. When you displace this container from here down here, you can calculate it. But I think that is the best way I can explain displacement to you. And the fundamental unit for displacement is meter. Fundamental unit of time, we all know that is second. To find the derived unit of velocity now, this is equal to meter per second. Meaning that velocity and speed have the same fundamental, have the same derived unit. They have the same derived unit. So, okay, let's move on. Let's look into another physical quantity. Let's talk about linear acceleration. Linear acceleration. Acceleration, the symbol for acceleration is small a. Everywhere you go, that's small a. And the formula for calculating acceleration is equal to velocity all over time. To get the acceleration of the car, you must get to know the velocity. So, or to get the acceleration of the body, sorry. Yes? Is there any question coming in? There's no question, I can move on. Velocity all over time. Do not forget to find the derived unit of linear acceleration now. We need to solve this. Sorry, I'm so sorry for the disruption. Velocity all over time. So acceleration, this one we are coming at meter per second square. This is the fundamental derived unit of acceleration. So to find the derived unit of acceleration now, this is velocity over time. Don't forget velocity is equal to displacement all over time. This is velocity. Diffusion over time all over this time. Velocity over time, diffusion over time. The fundamental unit of displacement is meter. Fundamental unit of time is second. Time, second. Therefore, acceleration will be equal to meter all this is as meter. So I'm so sorry for the disruption. I'm so sorry. So now the derived units of linear acceleration now can now become meter per second squared. This is just very simple. We said that the problem of calculating linear acceleration is velocity all over time. And velocity, the problem of velocity is that we always displacement all over time, all over this time. That's how we got displacement all over time, all over time. The fundamental unit for displacement is meter. Fundamental unit of time is second. Fundamental unit of time is second. This acceleration is equal to meter per second. This will give you meter per second squared. That was how we arrived at the derived unit of acceleration, which is meter per second squared. Meter per second squared. So let's look into another physical quantity. Let's talk about force. To calculate force, we must know the mass of the body and the acceleration. The formula for calculating force, symbol for force is F. Formula for calculating force is mass times acceleration. Mass times acceleration. That is formula for calculating force. Now, when you tell me as F is equal to M times A. Mass F is equal to, mass can be what? Kg. That is the fundamental unit of mass, kilogram, times acceleration. Do not forget the formula for calculating acceleration, which is velocity all over time. That's how we used to arrive at the fundamental the derived unit. So mass is kg, acceleration is velocity over time. We can move on. Force will be equal to kg times velocity. Displacement all over time. This one is velocity all over this time now. You understand? So force F will be equal to kg times, do not forget the fundamental unit of displacement, which is what? Meter all over fundamental unit of time, second, all over fundamental unit of time again, second. So force will be equal to kg times, this will give you meter per second squared. Therefore, the derived unit of force is now equal to kilogram meter per second squared. So that is why anywhere, everywhere, the derived unit of force is always kilogram meter per second squared. I can re-explain so those who don't understand can get the clear understanding of it. Force. We are trying to explain force as a physical quantity. I want to get the derived unit of force. Force, the formula for calculating force is mass times acceleration. The fundamental unit of mass is kilogram times acceleration. The formula for calculating acceleration is velocity all over time. That was how we arrived at this. Kg times velocity over time.
So first can move on at kilogram times to get velocity now. That is displacement all over time, Displacement all over time is your velocity. Now this time is the one down here. So that's the kilogram is equal to, do not forget the fundamental unit of displacement, which is what? Meter. Fundamental unit of time, second. Fundamental unit of time is second. Therefore, force will be equal to kilogram times meter per second squared. And the derived unit of force will be equal to kilogram meter per second squared. I hope you understand that. Let's talk about density. The symbol for density is P. And the formula for calculating density is mass all over volume. So mass all over volume. This is the formula for calculating density. How can we arrive at the derived unit of density now? Do not forget that mass, the fundamental unit of mass is kilogram. So you can move on by saying kilogram is going to be the fundamental unit of that. All over volume. Do not forget the formula for calculating volume, which is what? Area times height. We just discussed that. Area times height. So you can move on. This is equal to kilogram all over area. Formula for calculating area is length times breadth times height. This is length and breadth for the area, and this is the height. So kg, kilogram all over, the fundamental unit of length is meter. Fundamental unit of breadth is meter. Fundamental unit of height is meter. This is equal to kilogram all over meter times meter raised to power 3. Now, the formula for calculating density will be equal to kilogram kilogram per meter cube. Kilogram per meter cube, or kilogram meter raised to power -3. Like density. Let's move on. So another physical quantity that we look into is work. So to calculate work, so we use the formula. We use the formula force times speed. Do not forget the symbol for work is W, and the formula is force times speed. This is the formula for calculating work. With this formula now, we can arrive at the derived unit of work. First, do not forget that force is equal to mass times acceleration times speed. Speed, which is what? Distance all over time. This is how we calculate speed all over time. This is how we calculate force. If we don't split it like this, there is no way we can get the fundamental, the derived unit of it. Now, let's go about it. We cannot say that this is equal to m mass times acceleration is velocity all over time times distance and distance all over time. So we can now move on again. Mass times velocity is what? Displacement all over time over time times distance all over time. With this now, it is easy for us to get the derived unit of work. We can start placing them with their unit. The fundamental unit of mass is kilogram times fundamental unit of displacement is meter all over fundamental unit of time is second times second times distance. Fundamental unit of distance is meter all over time. Fundamental unit of time is second. So with this we can end up with kilogram times this one per acceleration, meter per second square times meter per second. Therefore, the derived unit of work will be equal to kilogram meter raised to power minus 2 meter second raised to power minus 1. This is the derived unit of work. Kilogram meter per second square per meter per second. Kilogram meter per second square meter per second.
Hello, sir.
Yeah. Yeah.
The first formula to calculate the work is force times what?
That is force and speed.
Speed. Okay, sir. Okay, sir.
Yeah, force and speed. So maybe let me recap so you can understand the concept. Formula for calculating work is equal to force times speed. And do not forget that the formula for calculating force is equal to mass times acceleration times speed. Formula for calculating speed is distance all over time. We move on again. We said mass times acceleration is velocity all over time times distance all over time. Acceleration. This A is right. It is because of this A that we got this velocity all over time. That is the formula for calculating acceleration. So we can move on and say mass times. Do not forget about velocity also have its formula. We need to break it down to the simplest form. So that's why we arrive at mass times displacement all over time. Displacement all over time is the formula of calculating velocity all over this time times distance all over time. How we arrive at this is, don't forget that mass, the fundamental unit of mass is kilogram, kg, times fundamental unit of displacement is meter, fundamental unit of time is second, fundamental unit of time is second, times distance over time, fundamental unit of distance is meter, fundamental unit of time is second. Therefore, kilogram times this acceleration, meter per second square, times meter per second. And this is how we arrive at this derived unit. So I hope you understand.